Hi everyone, welcome to Math Wizards 123. In this live stream we're going to take a look today at the distributive property and see how we can use it to write an equivalent expression. So I am going to set up a little tune here for you all to listen to the San Marcos Middle School beginning band while we're signing in, and then I'll give it a minute to see who's in the room with me here. Hi Alice, I think I see Alice. Lexi, is that you? Feel free to, as you enter the stream, if you want to go ahead and just give your first name and a quick hello, or throw an emoji out there for your friends. And we're just going to keep listening to this awesome music from the San Marcos Middle School Band. Hi Max, I see you've joined in. Good job. I'm glad you could be here on time. And hi Alex, awesome. I'm glad you could be here. And Ethan, hello. I'm just going to give it a few seconds here before I start to see who's with us. Alice, not in Wonderland. I love that screen name. Okay, if you're waiting, go ahead and just grab a sheet of paper and a pencil. I'm going to throw an expression out here, and so we can take a look at it together, and then we're going to move along and try to just practice a little bit more with the distributive property. Hi Isabella. Great, I'm glad you could be here. We're almost ready. Okay, I am going to start with this expression. I'm going to give you two numbers. I want you to just take a look, and then when you figure out what the value of this expression is, you can go ahead and type it into the stream. So how about 48 plus 24? What value do you come up with? 48 and 24. Okay, I'm seeing quite a few of you are coming up with the same value of 72. Great. All right, so let's think about 72. I want to see if you can come up with another expression other than this one that also has a value of 72. And then I'll pull 5 from the stream. What can you think of that you could use numbers and symbols that would represent the same value of 72? Okay, I see 24 added 3 times. Pull that together. Or using multiplication, 24 times 3. Any others? I'll take 2 more. 8 times 9. And I'm going to go ahead and just use this symbol here for multiplication. And wow, we even have using parentheses, 24 plus 12 inside the parentheses, all multiplied by 2. Okay, take a quick peek at the ones that I have on the paper here. Are there any, do these make sense to you? Remember that we want to think about also our PEMDAS rules as we evaluate expressions. Are there any that you see that you think do not actually equal to 72? If you think these are all correct and they are coming to a value of 72, you can give me a quick thumbs up. Now I'm not sure, Ethan, are you taking a look at the 8 times 9 and wondering if that's equal to 72? Or are you just giving me the reverse of a different expression? Okay, so far I don't see anyone disagreeing with the expressions that I've pulled out here on the paper. So I'm going to slide these aside. Now I'm going to challenge you to try to think. I want you to try to use these two operations. So we're going to take a look at just multiplication and addition. Okay, and then let's try to let's try creating an expression that uses multiplication and addition that will still lead us to 72. Okay, so I'm going to set up and just use the area model here. And I'm going to think about my original expression, okay, of 48 plus the 24. So how could I land on each of these numbers? Is there a factor that I could use that would help me to use the multiplication first before adding these two values together to equal 72? So think about 48 and 24. Are there any numbers that you know are a factor for both numbers that could lead us? Okay, so so far I see a 4 and a 24 and a 12. Okay, great job. I'm going to go ahead and just choose one for now. Let's try this one here. How about if I choose 12? What would I need to multiply by 12 in order to land on 48? Can anyone show me a factor that if I multiply by the 12, it will lead me to the 48? Okay, there we go. So I'm going to put this right up top over here, okay? And we're still going to be adding these values, together. So I'm going to keep the plus or the addition symbol in the center here. And now let's take a look at this value over here that's part of the 72, or the total of 72. What could I multiply by 12? In order to land on 24. Lots of 2's. Okay, so I'll put this one up here. Now, I'm going to challenge you. Is there a way that you can use parentheses in order to show that we need to do multiplication and then we'll be doing addition as well? So we'll use the addition symbol within this expression. But how can we write an expression that uses parentheses? Does anybody have an idea? What would go inside the parentheses? Just take a look at all of our numbers up here. Okay, so I see 2 people placing the 12, the factor, outside, and then keeping the 4 and the 2 inside. Okay, yeah, so I'm seeing that. Let's see. 12 times 4 plus 12 times 2. Okay, so I see that somebody has broken it apart into the 12 times the 4 and the 12 times the 2. That's another way that you can write an expression that would still lead us to the total of 72. But with this, if we want to use parentheses, we can avoid having to write that twice with the 12, multiplying it 2 times, and just put the factor here on the side 1 time. So they're both different ways that you can still land on the value of 72. So you guys did a great job with that one. Okay, let's try a different one now. So I'm going to pull this back over here. Let's keep our original expression. And I'd like you to think about what other number. Let's just try the same using 72 again. What other factor could I use instead of 12? A little bit of lag. Okay, let's see. Yeah, I think there is a little bit going on there. I think we're still in now. Okay, let's see, a lot of people want to use 24, so let's go for 24. I'm going to set that over here. And then if you can tell me what should I multiply the 24 by in order to land on the 48 over here. So what would be one of the factors that I could use that we can later put inside the parentheses? Okay, I see a 2 one time. Anybody else agree with the 2? Okay. All right, and then a 1 over here. So I'm going to keep my addition symbol in the center, and then a 1 up here. So using our area model, we can see how we can make it to 48 and the 24, which we need to add together in the end to be able to come to the value of 72 altogether. So now I'm going to challenge you to use parentheses instead of our area model. Let's simplify it and just use parentheses to show me what are the add-ins that we would then use to multiply by the 24. Okay, so I see the 24 outside, and then 2 plus 1 inside parentheses. Okay, great job. So if we see an expression like this, you know, we could use the area model sort of backwards in a way by just setting the 2 up top and the 1 here, and then moving through the multiplication first, and then adding together the 2 values to come up with our total. So we still land on 72. All right, great job. So now what I'd like to do is I'm going to try giving you the add-ins and the common factor and see if you can figure out what the total value is by distributing it. So what if I give you 5 and then 10 plus 4 inside. If it helps you, you can set up the area model and pull your factors where they need to go. And then take care of the multiplication first before you add together. So once you come up with the final value, I want you to come up with one final value. What would the whole expression be equivalent to? Okay, I think that's Lexi, came up to the 50 and the 20 using the area model by using the multiplication first. And then it looks like Alex took that and added it together, right? So we still have to take this, right, and combine the values for a final. You are correct if you got to 70. Good job. Okay, how about another one? I'm going to slide this over here. And let's try 12 times 30 plus 12. So maybe I have 12 baseball players, and they're buying uniforms, and you know, maybe the jersey costs $30 and then the belt and the hat costs 12. So how much would they need to spend altogether? So again, if you like using the area model, you can set it up using that. Pull your factors where they need to go. I see a 360 plus 144. And then I see a total of 504. Yeah, there does seem to be a little slight lag. We're just going to have to try to be patient today. I don't know what's going on with this internet. Maybe it's the rain. We'll see what happens here. We're just going to try one more after this. So, okay, I think this makes sense. So then combining the 360 and then adding that together, give a thumbs up if you agree with 504 as our final value. Yeah, it's very blurry looking. It almost looks like raindrops are on my computer screen. Okay, it looks like we all have the same idea. All right, great job. So the last one, I'm just going to try one more if the lagging is not too bad. Let's see here. Just test this real fast. Oh, okay. Now this time, what if I give you, instead of numbers only, what if I give you a variable in here? How can we use the same distributive property to simplify this? Now we won't be able to solve it if I don't know what the value of the x is, but could we simplify it using the same area model strategy? How could I simplify that? Okay, so if I pull this over here, setting it up top as we do, let's see, 90x, and then a 20, and then just keeping that addition symbol in the center there. It looks like you did a great job today. Even with all the lagging, I'm very proud of all of you. Awesome job, you guys. You are math wizards. Okay, so we're going to stop here. Great job practicing a little bit more with the distributive property. If you want on your own, you could try creating your own expression and then challenging somebody at home to try to see if they know how to simplify it using our distributive property or the area model. I'm going to go ahead and give you a little tune here. If you want to wave goodbye to your friends, I'll give you a little one more sound from our San Marcos Middle School band as we end the stream. Just make sure to throw a quick emoji to your friends before we go. And thanks for coming in today, guys. You did a great job. Bye, Jaden. Throw me an avocado. Where's my avocado? Didn't I get an avocado from you last time? Hey, bye, Alice Not in Wonderland. Bye, Isabella. We will see you tomorrow. Okay, everybody. Good job. We'll see you next time. Is that my avocado? Hey, there's my avocado. That's my favorite, avocados. Okay, bye, math wizards. We'll see you next Wednesday at 4.